Hi, today we're going through CCM8, Unit 5, Lesson 4. We're going to solve multi-step equations and equations with variables on both sides. This is a very complex process, so we have a lot of steps. Step 1, first clear the equation of fractions and decimals. Step 2, use the distributive property to remove parentheses. Step 3, combine like terms on both sides. Step 4, undo addition or subtraction. And lastly, undo multiplication or division. So here you see an example already worked out for you. We have 4b plus 16 plus 2b equals 46. So there's no fractions or decimals, so I skip step 1. There's no use of the distributive property, so I skip step 2 and move on to step 3, combining like terms. I see that I have a 4b and a 2b. And remember, when you combine like terms, you always circle your like terms and you include the operation symbol that comes in front of that term. Up here with 4b, it's understood that that's a positive 4b because there's no minus sign in front of it. So I have positive 4b plus 2b, altogether that's 6b. Then you bring down what you didn't use. Plus 16, so I wrote it there, equals 46, and I wrote it there. Now we move on to step 4 and step 5, undo addition or subtraction. So I'm going to undo the addition of 16 by subtracting 16 from both sides. And then 46 minus 16 is 30. And then lastly, I divide both sides by 6. My answer is B equals 5. Now, I did a lot of steps here, and I could have very easily made a mistake. To check my work, I simply plug in my solution of 5 for the variable b each time it occurs in the original problem. So I have 4 times 5 plus 16 plus 2 times 5. All of that should equal 46. 4 times 5 is 20. 2 times 5 is 10. 20 plus 16 is 36. 36 plus 10 is 46. So it checks out. My solution is correct. My solution was b equals 5. Not any of this. So this is my final answer. Okay, I'm going to show you lots of different types of examples, and I checked all of my work to make sure it's correct. I'm going to move you through this as quickly as possible. So example number 2, negative 2 times the quantity of b minus 4 equals 12. The first thing I need to focus on is using the distributive property. Negative 2 times b is negative 2b. Negative 2 times negative 4 is positive 8 because the negative times the negative is a positive. Bring down the equals 12. Now I need to undo the adding 8 with subtracting 8. So I subtract 8 from both sides. 12 take away 8 is 4. And I bring down what I didn't use, which was the negative 2b. So I'm left with negative 2b equals 4. Now I just have to divide both sides by negative 2. 4 divided by negative 2 is negative 2. So I come back through here and I insert my solution into the original problem and I simplify. Over here, when I check my work, I'm going to use the order of operations to check my work. So I'm going to start with the parentheses. Negative 2 take away 4 is negative 6. Negative 6 times negative 2 is positive 12, which is what I should get. So this is the correct solution. I checked my work. Number 3, I've got 2x over 3 plus x over 2 equals 7. That's the original problem, what's written in orange. I went through and I said, oh my goodness, I have a lot of fractions. I don't like working with fractions, so I'm actually going to multiply my entire problem by a common denominator. The common denominator between 3 and 2 is 6. So I'm going to multiply every term in this problem by 6, and that eliminates my fractions. Here's how I do it. So I drew parentheses around the left side of the equation and parentheses around the right side of the equation, and you see that I'm multiplying it by 6. So I have to go through one term at a time. 3 goes into 6 2 times. 2 times 2x is 4x. 2 goes into 6 3 times. 3 times x is 3x. And 7 times 6 is 42. This written in blue is my new, simpler equation. I can very easily solve that now that I've cleared out the fractions. 4x plus 3x is 7x, and then I just divide both sides by 7. X is equal to 6. That's my solution. Now I go back to the original problem, and I plug in 6 for every place there was an x. 2 times 6, and all of that over 3, plus 6 over 2, that should equal 7. So remember, I'm solving this part, my checking part, using order of operations. So I'm going to start with the numerator. 2 times 6, that's 12. And I can do this step and this step at the same time. 6 divided by 2, that's 3. Now I just have to simplify this fraction. 12 divided by 3 is 4. 4 plus 3 is 7. So that checks out. That's correct. And then sometimes you'll have problems that have lots of decimals in that. If you're like me and decimals confuse you and it's just a lot to work with, you can actually clear out the decimals by multiplying by factors of 10. So I can multiply by 10 if I have all decimals that are in the tenths place. Here I'm going to multiply by 100 to clear out all the decimals because I've got some numbers here that go out to the hundredths place. So if I multiply every term in this problem by 100, I clear out all of the decimals. So this 0.5a times 100 is now 50a. 8.75 times 100 is 875. You see how it just wipes away the decimals? 13.25 times 100 is 1,325. Now I just simplify by using inverse operations, or solve by using inverse operations. So I subtract both sides by 875. That leaves me with 50a equals 450. Just divide both sides by 50, and I'm left with a equals 9. This is the correct answer because I checked my work. Now let's do some problems together. In these problems, we have variables on both sides, so we'll just have to work it out. All right, number 1, 6x plus 3 equals 8x minus 21. The goal is to get all the x's on one side and all the numbers, constants, on the other. I like to kind of see what I'm working with before I move anything. Remember, to move something, you have to use inverse operations. So what I can do is I can undo the positive 8x by subtracting it. But look here, I've only got 6 x's over here. So if I subtract 8x, I'm going to end up with negative x's over here, which is fine. It'll work out that way. But I kind of like to make sure all my numbers stay positive. So I'm actually going to undo the 6x first and get all my x's on the right. It's okay. You can do it any way you wish. There's many ways to do this problem. This is just the way I like to do it. So I'm going to take away 6x from both sides, rewrite what I didn't use. 8x take away 6x, that's going to be 2 x's. And now I'm going to undo this minus 21 by adding 21 to both sides. See how all my numbers stay positive? And 2x equals 24. And now I just divide both sides by 2. X equals 12. Final answer. I'm not going to check this step, but you can always check your work. All right, here we go, number 2. I've got some decimals here in my problem, but if I've got a calculator handy, I don't have to always clear my decimals. So this way, in this problem, I'm not going to clear any decimals. I'm just going to work it out. I'm going to undo this positive 1.5h and kind of move it over to the other side so that all my numbers with my variables are on the same side. Rewrite what I didn't use. So 3.5 take away 1.5 is just 2. So I've got 40 equals 2h, and just divide by both sides by 2. H equals 20. Very easy. All right, over here, I've got negative 36 plus 2w equals negative 8w plus w. I need to go ahead and combine like terms on the right side of my problem first. Negative 8w plus 1w is negative 7w. Because remember, if a variable does not have a number in front of it, it's understood that there's a 1 there. So rewrite what I didn't use. Now, my only choice in this problem is to undo the positive 2w and move it over here. Because if I move the negative 7w's over there, then I wouldn't have anything left over on the right side of my equation. So I need to have something on both sides. So in this case, my only option is to move the 2w by subtracting it. I'm left with negative 36 on the left side and actually negative 9w over here on the right. Because 7w take away 2w is actually negative 9w's. Divide by negative 9. Negative divided by a negative is a positive. So w equals 4 in this case. All right, last one. You want to give it a try on your paper? The first step is to distribute. Make sure you distribute the 4 also to the 5. Now you have to undo the 4x. Divide by 2. X equals 10. Did you get that? All right. Now we've got some more complicated examples that I went ahead and worked out for you, but you can always just copy this down and go through it with me right now. So you've got some massive problems with fractions. The best way to handle this is to clear all the fractions. So I've got 2x over 5 minus 3/5 equals negative 1/5 minus x over 5. If you look and see, all your denominators are 5. So the best thing to do would be multiply this entire problem by 5, and it actually clears out every fraction. And you're left with 2x minus 3 equals negative 1 minus x. You're left with all the numerators. And it just so happened to work out that way because all the denominators were the same number. So we got lucky in that one. Now we just go through and solve just like we did the problems on the last page. I am actually going to subtract, I'm going to add x to both sides to get rid of it here. And that leaves me with 3x plus 3 equals negative 1. And then I'm going to undo the minus 3. And that gives me 3x equals 2. And I'm just going to divide by 3. And my answer is actually a fraction. And that's okay. X equals 2/3. As long as I check it to make sure I can check it using my calculator, plug it in, and it will work out. So it's okay to have some answers as a decimal or a fraction. Here we go. Number 2, 3x over 5 plus 1/15 equals 4 plus 2x over 3. And I look at my denominators. I have a denominator of 5, 15, 1, and 3. The common denominator here is 15, so I'm actually going to multiply this entire problem by 15 to clear all the fractions out of the way. This is how you do it. 5 goes into 15 3 times. 3 times 3x is 9x. 15 goes into 15 once. 1 times 1 is 1. 4 times 15 is 60. 3 goes into 15 5 times. 5 times 2x is 10x. Then you can go ahead and solve your problem. So I'm actually going to subtract 9x from both sides and simultaneously subtract 60 from both sides. It's okay, I can do that because the x's are affecting the x's and the constants are affecting the constants, and they're not really crossing paths. So once I do that, I get my final answer, x equals negative 59. Sometimes when you try to solve an equation, your variables cancel out completely. If what is left is a true statement, then your answer is what we call an identity. Identity means that all real numbers are solutions. Here are 2 examples worked out for you. 5x plus 6 equals 2x plus 6 plus 3x. The first thing I need to do is combine like terms over here on the right. 2x plus 3x is 5x. And then I went through and started solving my problem by subtracting 5x from both sides. And those 5x's canceled out. I'm left with 6 equals 6. That's a true statement, so my answer is identity. Number 2, I actually have to distribute first. So I'm distributing 2x, is 2 times x is 2x, 2 times 3 is 6. So once I wrote that down, I realized, hey, I've got something that looks the same on both sides. Let me try to start solving. And I started solving and I realized, oh, I just get 6 equals 6. That's a true statement, so my answer is identity. Sometimes when you try to solve an equation and your variables cancel out, what's left will be a false statement. Then, if that's the case, then your answer is no solution. This means that no value of your variable will work. So here are 2 examples where we get no solution as an answer. 4x minus 10 plus 2x equals 6x minus 3. Go ahead and combine like terms. 4x plus 2x is 6x. Rewrite everything that you didn't use. Then go through and start solving your problem. I subtracted 6x from both sides, and you know what? That just canceled out. What was remaining is this statement. Negative 10 equals negative 3. That's not a true statement, so this, the answer to this problem is actually no solution. And down here, number 2. At first glance, it looks like I'm dealing with the same numbers on both sides of my equal sign. But if you look and you go through and you distribute, you actually get 3x plus 12 equals 3x plus 4. When you go through and solve, you'll find out that what you're left with is 12 equals 4. That is a false statement, so this is no solution also. All right, hope you learned something. Maybe. Why aren't you shutting off?